Okay, so we spent some time looking at nets. And so remember that the net is the flattened out version of a 3D shape. And so with this lesson, we're moving into chapter 4.3 and we're going to look at how to calculate surface area of a specific 3D shape. So this one is called our rectangular prism. So remember that a prism has two faces opposite each other that are exactly the same. So these two sides, these two faces are going to be the same in terms of surface area. They're the exact same shape and size. And so we can call this a prism. So it's a rectangular prism because our two congruent faces are rectangles. So I've chosen this 3D shape here. One of the sides is 3 centimeters, one is 8 centimeters, and the other is 5 centimeters. Remember that you can look at your 3D shape and know that the opposite side here is also going to be the same length. So if this one is 5 centimeters, so is this one. Okay, so a rectangular prism, I've drawn out a net here for you. So the net is like the flattened out version of our rectangular prism. So notice I've drawn these little notches in here. It's not supposed to add more confusion. It's just supposed to clarify the length of all of these sides. So one notch is equal to our shortest length. So the shortest possible side on our 3D shape is 3 centimeters. Okay, so one notch. 2 notches is 5 centimeters. So notice I've put 2 notches here, but I did not write a 5 because it's supposed to indicate that this is a 5 centimeter side length. 3 notches is 8 centimeters. Okay, so all of these are 8. So I've drawn out my net. And now we're going to calculate the surface area of our 3D shape. So surface area, there's a specific calculation we're going to look at. So surface area is equal to the sum of all 6 rectangles that make up your net. So notice we have 1, 2, 3, 4, 5, 6 rectangles when we flatten out our 3D shape. So all we're doing is adding up the area of the rectangles that exist on the net. Okay, so here we go. So I've shortened surface area to SA, okay? And now before we move into our calculation, actually we need to name our faces. So we're gonna name this one Bob and this one Joe and this, no, I'm just kidding. We're gonna name them letters, okay? So I'm gonna call this guy here A. I'm gonna use all different colors so we don't get confused. Our next one is going to be B. Our next face is going to be called C. Oh, I was wrong. This guy is gonna be C. And this one is B. Okay. We're gonna call the next one D. And followed by E and F. Okay. So here we've labeled all of the faces and we're going to use this to calculate out our surface area. So surface area, SA, is the sum of all of the rectangles that make up your net. So I know this looks like a lot, it looks like a long equation, but once we plug everything in, it will look much simpler. So we have to add up, remember sum is addition, we have to add the surface area of A plus the surface area of B, surface area of C, surface area of D, E, and F. We're adding those all together. So we need to figure out the surface area, or the area, of each of these rectangles. So if I look at A, I know that one side is 5 centimeters and the other side is 3 centimeters. So we know that calculating area is the same as saying length times width, okay? Or base times height. Either of those will give you your area. So we can see that 3 times 5 is going to give us our area of A, okay? So going back down here, surface area of A, 5 times 3, or 3 times 5, okay? So we've got that one done. The next one, moving on to surface area of B. I've got 8 times 3, and I've plugged that in there, okay? Looking for the light blue face, so C here is 8 times 5. I forgot to put my little notches in there, but because this side is 5, then, oh, my marker's running out. Then this side is going to be 5 as well. So we've got 8 times 5. Oh, which one was I looking at? Uh-oh. D. Yes. 3 times 5, not 8 times 5. I'm sorry. 3 times 5. There we go. And that's D. So for the surface area of E, we're looking over here. We see that 8 times 3 is going to be our calculation. We plug that in. And the last one is going to be 8 times 5. Now I want you to look at these 6 multiplication equations and see if you notice anything. Okay, so you might notice that A and D are the same. B and E are the same. And C and F are the same. Okay, we're gonna go back to this later, but I want you to keep that in mind. Okay, so if I'm gonna do this the long way, I'm going to see that 3 times 5, I have to figure this out, and I'm going to put my answer in here. So 3 times 5 gives me 15. I'm adding this up with the surface area of B, which is 8 times 3, so I get 24. Moving along, we're adding that to the surface area of C, which is 8 times 5, and I get 40, okay? And then I'm doing the same ones again. So surface area of D, again, is 15. Surface area of E, 8 times 3 is 24. And surface area of F, 8 times 5 is 40. So now we need to talk to Calculator Ben and see what our final answer is. Or we can put our mental math to the test. So I've got, let's say, 40 and 40, so 80. I add 24 and 24, 48. And 15 and 15, so 30. Add these up. And we have 200 and, oh my goodness, 158 centimeters squared. Because remember, when we're calculating area and we're multiplying a centimeter unit by another centimeter unit, we need to put that little square symbol in the top right corner. So 158 centimeters squared is the final total surface area of this rectangular prism, this polyhedron, this 3D shape. Okay, so I'm going to post a picture of this full problem. And then you can see the whole thing all at once. I hope this made sense. And please, please, please do not hesitate to email me or to message me on Edsby if this does not make sense to you. And our next video is going to show what we can do about these ones. Remember, they're the exact same equation, so we're going to look at how to make this a little bit simpler and a little bit faster. Okay, good luck. Okay, part 2, we're finishing up calculating the surface area of a rectangular prism. And so we did notice a little bit of a pattern here. We noticed that the surface area of A was the same as the surface area of D. The surface area of B was the same as the surface area of E, and the surface area of C was the same as the surface area of F. So if we look at our net, we can see that that's true, right? So A and D, they're the exact same size and shape, the same area. B and E are the same, and C and F are the same. So I have a real life rectangular prism here. You might have one in your house. You might be able to find a cereal box, a Kleenex box, something that is a rectangular prism. Okay, and so we can see that this side is the same as this side. This side is the same as this side. And this side or face is the same as this face. Okay, so we know that there's 2 of each type of face. So we can make our calculation a little bit shorter and easier here by doing this. We can say that we can multiply 2 times this equation. So we have 2 times the surface area of A, which is 3 times 5. We can add this to 2 times the surface area of B, which is 8 times 3. And we can add that to 2 times the surface area of C, which is 8 times 5. Okay, so we want to do the brackets first. Remember, BEDMAS, brackets, then exponents, then division and multiplication, then addition and subtraction. So we want to do the brackets first. Okay, so we've got 2 times what's in our bracket is 3 times 5, so 15. 2 times 24 plus 2 times 40. So 2 times 15, we get 30, plus 2 times 24, we get 48, plus 2 times 40 gives me 80. And in the end, we're left with 158 centimeters squared, which is exactly the same answer that we got using our previous method. So you can either add up each of the surface areas, so you would add those 6 equations, or when we notice the pattern, we could simply take 2 times the surface area of A plus 2 times the surface area of B plus 2 times the surface area of C to get our final answer. So that was calculating surface area of rectangular prisms, and we're going to try out a few different shapes, 3D shapes, later this week.